Hello, everyone out there. Welcome to Solve It Out. This is Annie here, and today I'm going to create a weather forecast web app. Here, as you can see, we can search any place. Currently, the default is Kolkata, India. And on searching, you're going to get the date, the location, the highest temperature, lowest temperature, relative humidity, and the average wind speed. Also, the temperature and the hour um, graph is being displayed in the below. As I hover on it, you can see the temperature, the wind speed, and the relative humidity of that particular time. The date is given here, and the time is starting from 12 a.m. at midnight, and we are going to travel the whole day, and we can go through the highest and the lowest temperature in the graph. So this is going to be our project today, and we are going to build this on Next.js. Before starting the code, let's quickly search another place, like maybe another city or another country. For another city, I can quickly write Delhi and search. You can see the location here is now Delhi, and the date is June 27, and the relative humidity, the highest temperature, lowest temperature, and the average wind speed is all here. Onto the graph, if you hover it, you can see that on each time, this is our tree data. If I check on the 5 p.m., the data has been this one, on 9 p.m., the data is this one, or maybe the 7 a.m. So this is like the city part. Let's change the country and place something like New York. You can see now our location is New York, and we are getting all our datas here, the highest temperature, lowest temperature, and it's beautifully represented in the graph format. So this was the quick demo. Now let's start our code. Now I have already created the Next.js app using npx create next app at latest. So here you can see we have the Tailwind CSS, the TypeScript, and the Next.js installed, that to the current 14.2.4 version. I have created some changes here, like from page.tsx, I have removed the initial code and just imported the weather component. Inside the components folder here, I have created the weather.tsx, just the boilerplate code here. So now we are going to run it and initialize our project. You can see here our weather is written here. Now in this weather app, I'm going to use two kind of APIs to fetch the weather details. First is this one. It is the Open-Meteo open source weather API, where you can find different type of APIs here. Like here, the three most examples are given here for the forecast and the current data for the last 10 days and the historical data. Many more are there. If you go to their documentation part, you can check here that on calculating the latitude and the longitude, you can find this many things if you want to show it on your website. So I have just chosen a few of them. Next, I'm going to talk about the Open Weather API. This is another API that I'm going to use. Here, you have to do the login here to access this APIs. If I go to the API part here, first you have to log in and then you can get an API key. I'm using two different APIs because on one API, I'm getting the latitude and longitude of that place on basis of the name. And from another API, I'm actually getting the whole data set. Also, the chart that we will be creating, it's on the Recharts. We are going to use that. If you go to the install part and go to the API here, You can see different type of charts here, like the area chart, the bar chart. There are different type of chart here. I'm using the line chart here in my project. So this is all about it. Now let's do some package installation. We are going to install Moment.js, Recharts, and Axios. We are also going to use Daisy UI. After installing, just go to tailwind-config.ts and inside the plugins, paste required Daisy UI. Then the classes of the Daisy UI will come into view. When you are doing the login in the Open-Weather website, you are going to get an API key there. Once you get your API key, you have to create a .env.local. I have created here .example to show you all. You have to create .env.local and set this key name, that is the key ID, next public weather API key, and then paste up your key that you got from the Open-Weather website. I have already done mine. Now, next, let's go to the weather.tsx and fetch our APIs. At first, I'm going to create a function where I'm going to fetch the weather data. Inside the function will be, of course, a sync function. I'll write a try catch block and console.log out the error. We'll create here a loading state above the function, import the use state, and also write on the above the use client. We'll set the loading state to true till our function runs, and we'll write finally here, setting it to false. Now, inside the try block, I'm going to create a constant variable geocode response where I'm going to fetch an API. Imported the Axios, and now let's go to the details of the API. Inside Weather API, if you scroll down, you're going to find a geocoding API here. You go to the API docs. On scrolling down, you'll find how to do the API call. You can see it. This is our API, and we are going to pass parameters like city, name, or state code, or the country code, and we can set the limit, and also our app ID will be the API key that you are going to get when you do the login. Here, these are the parameters. Here is the API response, like what you can get on in the response of it. You can actually get the latitude and the longitude part, whatever name you give. So that's we are going to use. So we are going to copy the API call from here and paste it in our code. After pasting it, we are going to make some changes here. I'm going to create another use state where our location will be fetched here. This is our location and the set location use state, and the default value here is Kolkata, and this is our string type. This location we are going to put in the input field that we are going to design, and on the input search, this location will search in this API. So how to put this location in the API? We are going to remove this city name part, city name, state code, and the country code, and we'll give a dynamic value here, that is our location. We'll set the limit to 1. We are not going to give any dynamic value for the limit. And for the API key, I'm going to write process.env.next public weather API key. This will be our dynamic API key, our location, and the limit is 1. Here, below the fetch weather data, I'm calling it inside the use effect, and when it will be called whenever there will be any change in the location. That's why we are using this use effect, and in the dependency, we are using the location. Now, we'll quickly create the input field. Let's go to the div. Want to give this main div a background image that will go with our app. I have used the image from Pixels and given a background size cover, background position center, and minimum height 100 view height. Next, we'll add some Tailwind CSS classes. We'll create a div with the overlay, background black, background opacity 60, min height screen, adding 5, max width 5XL, MX auto, grid, place item center. Also, we'll add a div of flex, display flex, justify evenly with full and item center. We'll write here a h1 tag with the text 3XL, font bold, text center, margin bottom 4, and text white. Then we'll write our input field inside a div. First the div with some minimum classes. Next our input field. Here you can see our type will be text. A value will have a useState hook. That is, it's not a hook. It's a useState parameter search location. On change will set search location to a target value. We have a class name which contains a shadow, a rounded medium, outline none, padding, focus, and focus ring color. And placeholder will have enter location. Now let us quickly create this search location use state. Before that, I'm going to write the button here. On button, we'll have a handle search, or you can also change the div to form right here on submit, and then the handle search. And our button will have a type of submit. So quickly let's write this handle search and the search location use state. For the use state, this will be our search location, set search location, and the initial string will have Kolkata as its default. Below the use effect, let's write the function and see inside the set location, we are passing the search location here, and our location we are going to fetch inside this API. Now, as we have done the input part, we can now check the geocode response if we are getting it or not. Let's first check our UI. This is our UI working fine. The background with an overlay, the weather forecast, and the Kolkata with this search button. Now, if I go to inspect and go to console, you can see we have an object here. If I open the object, click on the data, you can see an array where you're fetching the country, the local names, the name, state, the latitude, and the longitude. So this we need the latitude and the longitude part. So our data is coming fine. Now we have to restructure our data and call it in another API. The next step will be destructuring the latitude and the longitude. So after this console.log, I'm going to destructure the latitude and longitude from geocode response and taking the initial 0th data as it is an array. Next, we will fetch another API that is from Open-Meteo. We are going to fetch the forecast and current API. If you see the raw API here, you can see this is the domain name and the forecast is using a latitude and a longitude. So we have already fetched the latitude and longitude. Now we can place our dynamic latitude and longitude value in this API, and then we can fetch this current time and hourly time, wind speed, temperature, and relative humidity. Here, we're going to create a const response with an await axios.get, and we are going to paste the API here. Copy and paste. We'll change the quotes to backticks so that we can add the dynamic value. Here on the latitude part, you can see this is the hard-coded data. We are going to change it to dynamic. Also the longitude part. And our API is ready to fetch. We'll destructure the data from the response and we'll try to show it in console.log. If we go in the inspect here and console, you can see here the latitude and the longitude coming. Is an object here with the current time, current units, hourly time, relative humidity, temperature, latitude, longitude, time zone. So our API is working fine and it's fetched correctly. Now let us destructure more and make it ready for our graph. First, I'm going to create an interface to define the types of the data that I'm going to destructure. So this is the weather data interface where it will have a hour field, temperature, wind speed, and relative humidity. Next, I'm going to define a use state which is going to follow the weather data interface. It will be its type. After that, I'm going to define a constant max hours. The value will be 24 because I want a time of 24 hours duration. So the max hours will be 24. Next, I'll define a function here. First, we'll store the function in a formatted data variable where it will follow the weather data array type. I'm going to first work with the hour field in the data. So data.hourly.time.slice. So first I'm going to slice the hour. The duration is 0 to 24 hours. Next, I'm going to map out the inner values now. First, we'll destructure the hour field where I'm giving a new date time, passing the time here and keeping the hour to 2-digit and minute to 2-digit. Next, after the hour field, going to destructure the other 3 fields, that is the temperature, where you can destructure by data.hourly.temperature, wind speed, and relative humidity. So first I did a slice, taking the duration, and then I map out the data. Now I'll pass this formatted data in our set state. In our set weather data, I passed the formatted data. So in our graph, if we use the weather data, we can fetch this whole thing. Next, we'll calculate the highest and the lowest temperatures, also the average humidity and the wind speed. To calculate the highest and lowest temperature, I'm going to take 2 state variables, that is the highest temp, set highest temp, lowest temp, set lowest temp. And the use state is either a number or null, initiating with a null value. Below set weather data, I'm going to loop over all the temperatures that is present in the formatted data. So I use the map function on the formatted data and loop through all the temperatures. Now for highest temperature, inside set highest temp, I'm going to pass math.max with the spread operator, the temperatures. The spread operator usually kept a copy of the temps variable, and math.max will find out the maximum temperature out there and it will get stored in the state. Next, in a similar way, we are going to find the lowest temperature using math.min. So our highest and lowest temperature is done. Now our average humidity. For this also, I'm going to create two states, that is average humidity and average wind speed. It's also initiated with string or null, and the initial value is null. Like the same way as the temperature, I'm going to loop through the data of wind speed and humidity inside the formatted data. Inside set average data, I'm passing the wind speed.reduce function where I'm doing the addups and then dividing it with wind speeds.length, and up to decimal point 2, I'm keeping the value. Similar goes to set average humidity. We'll first imply the reduce function and sum it up divided by the humidity.length up to decimal point 2. So our average wind speed and average humidity function is completed. We will first showcase our data and then we are going to portray it in our graph. So first we are going to check the loading state, that if the loading is false, then we are going to show the data, and if it is true, then we are going to show some waiting image. So below the input field of search, we are going to put this check that if it in loading state, we are going to opt for an image, we'll show an image here, and if not, then we'll show the data. As I'm using a gif.gif file here, so I have given this unoptimized field so that it doesn't show up any error in the console. To show the data, first going to put some CSS class in the first div, that is a display flex, a flex direction column, justify center, item start, max width 5 pixel, margin auto with 100%, and a gap of 2.5 rem. So inside this div, going to add some more styles. So here a text white, a overlay function, this is of the Daisy UI, a padding, a background black with the opacity 50, display flex, justify content around, space around, max width 42 rem, and this is MX auto, item start with full gap 10. This is for the line height and letter spacing with a text of base. Now inside this, first we are going to call the date, location, and relative humidity. Now for this we have to import our moment. Our moment is imported. Let me format it. Yes. So in date, I am passing the date using the moment.js, and it will going to show as the normal date. The location is from the location that we got. We are passing our search location in set location. Here we are getting the location from here. And the relative humidity is the average humidity, and its unit is percentage. Next, we'll have our other three datas, that is the highest temperature, lowest temperature, and average wind speed. We have already find this out in our function previously. So we are going to save and now check how it is exactly displaying in our website. So in our UI, you can see that the default value is Kolkata, and it's showing the date, the location, the relative humidity, highest temperature, lowest temperature, and the average wind speed. It's quite running fine. Now let us change the city name to Shimla maybe, and then search it. You can see the GIF or the loading state, and now the location is Shimla, and it's the highest and the lowest temperature, and the current date, the relative humidity, and the average wind speed. Now we need to display this data in our graph. To display our graph, we need to start with a bunch of imports. So at the top of the page, I'm going to import Cartesian grid, x-axis, y-axis, tooltip, line chart, line, and legend from Recharts. Next, we move down, and below our overlay class, we are going to display our graph. Start with some heading and some div with some CSS classes. This is our div, and this is our heading with temperature, and this is our starting div where we have overflow x auto. That means we can horizontally scroll it. First, we are going to call the line chart. On the width of the line chart, it is dependent on the weather data length, and this is the height, and as the data I'm passing directly the weather data. Inside line chart, I'm going to give the x-axis, y-axis, and the Cartesian grid. X-axis data will have the data key as the hours it will portray, and the y-axis, it's going to portray the temperature. So no need to define it, it will take by its own. And this will be the color which I want it to be white, both for x and y axis. This is the Cartesian grid, that is on the grid line. As I'm using the line chart, the grid I want must have this light gray color. Then I wanted to have the tooltip, that is whenever we are going to hover, we want to show the data there. And the legend is for showing the details of the data, that is which line is dedicating or depicting which field. If you go to the line chart docs, you can find out here that this pointer is the the tooltip, and this part is the legend part. This is our y-axis, and this is our x-axis where we are passing the data key. Okay, this is our Cartesian grid, that is the grid on which the line is drawn, and this is our line chart, the whole diagram, which is the width, height, and the data. Also, you can give margin here, but I prefer it not. Okay, we are left with the line types, that which line will represent exactly which data. So let's go and add it. I wanted to show 3 data here, so there will be 3 lines. Cell type monotone, and data key is different for each line. You can see one is wind speed, one is temperature, and one is relative humidity. And the strokes will have different colors to depict it differently. Now let us save it, and let's check how is our data actually showing in our website. You can see here our graph is present very beautifully, taking almost the full width, and we can easily do the horizontal scroll. You can see we are exactly starting from the 12 a.m. and it's continuing to 1 a.m., 3 a.m., 5 a.m., and it's going around the whole day and ending at 11 p.m. Okay, so this our last grid will be depicting like the 12 p.m. part, and each grid point is exactly showing the difference of the wind speed, temperature, and relative humidity difference. And with the color of the line, you can easily differentiate which line is depicting exactly which field. Our legends are also showing in a cool way. Now, this is almost done. Our weather app. Let's check it for another country. Let's do a quick refresh. Now is the default Kolkata. Let's change the country and type London. And see, the location is London with the highest temperature and the lowest temperature given here with an average wind speed. The date is showing, and this is the way it's depicting in the graph, and you can check any times temperature directly on just hovering. Let's also check some other like Seoul. If you search it, it's also present here. So you can check any country, any city out there, because as we are searching it with latitude and longitude. It's really easy to search and depict it in our graph. Hope you like this project. If you like it, do comment down below, and I will be sharing the code in the description part. So, this is Annie signing off today. Let's meet in another new and interesting project.